Welcome to Keen on Green with Evan Rigsby, the podcast that dives deep into the world of environmental consulting from a multitude of perspectives. Join your host, Evan Rigsby, as he explores the intricate challenges and innovative solutions within the environmental sector.
Hey everybody, it's Evan Rigsby, and I am so excited for this end of year episode of Keen on Green. Coming off Thanksgiving, a lot to think about, and I've just been so thankful for this community, some of the leaders we've brought on, and especially your feedback. That being said, I have a very special guest for our December episode. It's my friend Pete Belmonte over here in Texas. Pete is an energy expert, bringing over 30 years of experience in power generation, in renewables, in oil and gas, and he comes from a multitude of experiences helping clients for decades in this space. I'm really excited for this episode to pick his brain on his thoughts on the industry, but also sharing some of his career insights and where he is today and some of the stuff that he's seeing and even projecting what's going to be happening in the future. Without further ado, Pete, thanks so much for being on today.
Hey, Evan, great to be here. Thank you for having me. Appreciate that.
So I think one of the areas I would absolutely love to start on is I ask folks from, all these different backgrounds, remediation, power, air, how did you get in your space? Was it something that you kind of fell into? Was it something you always had an interest in? How did you get started in this space?
Wow, great question. I tell people I didn't choose the power industry, it kind of chose me. It goes back to when I graduated in 91, right? From Manhattan College, now Manhattan University in the Bronx or Riverdale, right? Just north of the Bronx. And at the time, it was during the first Gulf War. So, the bottom kind of fell out in the job market, whereas the year before, everybody that was graduating probably had 2 or 3 job offers. And in 91, the job market completely crashed. And we were actually getting recruited by the CIA to go shut the oil fields down in Iraq. And I was like, yeah,
Really?
I'm not doing that unless I bring Uncle Vito and Luigi with me, right? And so my own personal protection. And so I want to work, getting a gig with the EPA. I thought I was going to work for the government, not work for the government. I thought I was going to work for a refinery or being in an oil field or whatever. When I worked for the EPA, couldn't stand it, couldn't stand the bureaucracy. I had more ambition than that. Went to consulting and dabbled in, power. That was my first taste of power, steel mills, pulp and paper, right? And at the end of the day, I wound up doing a lot of waste energy work, retrofits, construction management. They were the first MACT standards that they had to meet. And so I was at waste energy plants around the country, managing all those retrofits, and then got into industry and at Trigen and in White Plains, and then 2 years after that, they wound up integrating us into Tractable. They were always owned by Suez and integrating us into Tractable. So I came down in '02, and been in power ever since that. Right, I went from smaller inside the fence, behind the meter type projects to large utility scale 700, 800 megawatt projects. Some were a little bit smaller than that, but yeah, that's how I got into power and stayed in it for a very long time.
I think that's an interesting point. And I talk with a lot of folks where, they're on the consulting side or they might be on the EPA side of the fence. And obviously those are 2 very different worlds. And, when you had that switch and you were kind of starting out on the EPA side, you went to consulting, how was that transition for you?
Oh, it was good for me. That's where I learned the most, right?
Okay.
You learn all the basics in college, right? And you think you're gonna do, the Bernoulli equation and all that kind of stuff, right? And pumps and pipe flows and all that kind of stuff. And but no, it's when you enter the real world experience, all that stuff. Now at that time, everything they started coming, everything by hand. You were doing all the calculations by hand or a VAX computer. You know how many nights I spent in the computer in the computer room overnight running models, right? uh,
Mm-hmm.
chemical engineering programs and simulations and all that. And then Windows came out roughly in 91 or whatever, and Excel and all that. So,
Mm-hmm.
as the program started coming out, it made your job obviously a little bit easier, and you didn't have to worry about doing everything by hand. Because if you messed up, especially with those computer programs, you had to go back and search for where you missed the comma or the
Oh
semicolon
no.
and all that, right? And even if you go back years before that, when my godfather, may rest in peace, they had punch cards, and it was even worse. So,
Oh
um,
no.
yeah, it was. The the education's come such a long way, and now you have all the programs. But when you're in the field and learning stuff, watching and seeing and turning wrenches and all that kind of stuff, right? I've done startup and commissioning and outages and things like that, and that's where you really the rubber meets the road, and you learn a lot by being out in the field and doing. So um, that experience was great because as a consultant, I was a runt at the time, and I was always thrown out in the field,
Mm-hmm.
especially at the steel mill. The steel mill. I learned a lot because I was seconded there as the environmental manager for a few years, several times a week, and got to interact with the guys at the plant, and I mean some really smart people that had the trades, and you'd be surprised. From an education standpoint, learning on the job was provided some education like that you wouldn't see in a classroom, right? Same thing with and I applied to growing up on the streets, so to speak, and how I learned becoming quote unquote street smart. Some stuff that kids just today are just book smart, and they don't have the common sense that goes with it. So it's a little bit different.
Well, I would love to kind of just hit on that topic quick because I think, and I know you and I have kind of talked about in the past, COVID was a weird time, and
Hmm.
people were doing a lot of video calls and having,
Oh
I
yeah.
wouldn't say as much of that in-person interaction. You talk about the field, you talk about some of the great people you've met at different points in the process.
Yeah.
Um, let's go back to that. I mean, what were some of the folks, or if anything, if you had any stories where, as you were in those early years soaking things up, the importance of seeing those parts of the process and the different folks along the way, 'cause that's invaluable.
Yeah, during COVID specifically. I mean, I'll give you an example. We were doing a middle of a due diligence project for about a dozen power plants at the time, and they kept scheduling the site visits, and they had to keep pushing them back to the point where we never did them. The
Hmm.
plants were locked in. They were bringing food and all this, even the plants that we operated when I was with CAMS at the time.
Hmm.
And we they brought in RVs, and the guys just stayed at the plant during the shutdown, and food was
Hmm.
catered and all that kind of stuff. But I remember we doing due diligence, and we had to do it by teams, and it was really difficult. I mean, I like to kick the tire, so to speak, see it, feel it, touch it when I'm out of the plant, right? And you just can't do that by doing it like this, right? The guy,
Hmm.
first of all, it's noisy, you really can't hear him, right? And he's going in all parts of the plant and showing us stuff, and we're all in Messenger. Like, I really don't, can he turn the camera? 'Cause he's with his phone, right? And doing you know, trying to scan the plant, certain parts of the plant, and all that kind of, and it was just couldn't really do it, right? Basically, we had to go based off of questions and ask a lot of questions of the facility and several times over,
Hmm.
several meetings by Zoom, Teams,
Hmm.
whatever, and
Hmm.
then go through the engineer's reports and operational reports and all that kind of stuff, right? To really get to the bottom of it. So it was more deep dive into the data that they were providing instead of going to see it, feel it, touch it, where you kind of get a better sense of the system, right? I mean, I've done a lot of due diligence in my career. Probably been in about 60% of the power plants in this country at one time or another. A lot of
Wow.
them, several of them more than once. A lot of them have shut down because they were coal. But
Hmm.
they want the senior guys there doing that kind of work, and so yeah, so during COVID, we were doing it that way, but yeah, I mean, there's and it shut down a lot of programs, right? From an education standpoint, kids in school. I mean, I know my kids, right? My two boys had to go home. They were in New York at Binghamton and Cortland. They had to go home and finish online. My daughter
Hmm.
had to come home from Caldwell University, New Jersey, ruin her senior year of volleyball, right? My stepson was already home. He did a 2-year program, but down in Navy. But yeah, I mean, it ruined, it delayed their programs. Like my boys, when they graduated, I couldn't even go up to their graduation. I had to watch it on YouTube. And one of my sons didn't even walk, right? He
Really?
wound up getting into med school and he walked at med school, but he didn't get to walk for his undergraduate, right? And my stepdaughter, she wound up finishing her degree online at another university as a
Hmm.
result of that, right? And so yeah, it changed a lot of things, a lot of perspectives, coming out of COVID and what have you. And I guess we do things a little bit differently, but
Hmm.
there's nothing like seeing, feeling, touching, right? I mean, shoot, even when I shop, I gotta go to the store. I don't like buying anything online. I gotta,
Yeah.
you know,
No,
see it
I'm
and
the
touch
same
it and all that
way.
kind of
And I think off of what you're saying and kind of going way back there, one of the questions I get asked, especially from younger consultants, is like, how do I get started? And I think there's a great deal of, in a lot of ways, overthinking it or maybe imposter syndrome. But I'm sure for yourself, you had a lot of great mentors along the way and people that, as you were going through those experiences, really help to educate you and carry you and show you to open doors and and so forth. One of the things I love about you is you are a networker. You reach out, you are always talking with new folks or conferences. I guess going back to younger Pete for a sec, what were some of those experiences? Did you have mentors along the way and
oh
how
yeah.
did that work for you?
Yeah, absolutely. I mean, when I first got into consulting and doing air quality work and learning the modeling and all that kind of stuff, I had a great mentor. His name was Paul Eisen. He really got me into doing, all types of air quality projects, right? Power, steel. I mean, we did one of the last projects down in Puerto Rico at the time at Cambalache, which was an oil-fired boiler, and
Mm,
that was one of the
mm,
last units that ever got built down there,
mm,
if I recall, in the mid '90s. So yeah, I mean, and then and then being on site, right? I mean, you learn as you go, and you're gonna make mistakes along the way. But the thing is, that's how you learn, right? You're
mm,
gonna make mistakes, and don't be afraid to make mistakes, okay? You can't be afraid to make mistakes. Now there are mistakes that you can make that could, don't get me wrong, that could impact others, harm others, right?
mm,
At the steel mill, for example, one of the biggest problems that we always had was the roof leaked and it would puddle on the ground inside the warehouse or the building where the electric arc furnace was housed, right? So when they
mm,
would now you could put water in the hot steel or let it, but if you have a puddle and you have they called it the kettle, right, where you melted the steel. Now, if the crane is taking the kettle and sending it down, and
mm,
the guy doesn't see a puddle of water, well, it creates a really quick reaction, right? And it flashes, and it's a boom. I
mm,
mean, it knocked off the roof of the quick check down the street, and
mm.
so you have to be careful of that kind of stuff. But if you make mistakes, you got to own up to it, and be able to
Yeah.
you know learn from it, right? So it doesn't happen again, right? And I've been in situations where stuff is going to happen. You got to be able to look for your exits, know where you're. Like
Hmm.
if you're in a steel mill, and for example, and the billets are going through where they 2x4s or 4x4 billets, chunks of
Yep.
steel, and you're taking them into rebar, and it gets stretched, right? Because it's molten on the inside but pliable on the outside, and doesn't hit the thing right, it'll cobble. And if you're out on the floor and that starts cobbling at high speeds, and you better find the corner and duck and hope that that doesn't that cobbled steel doesn't find you, right? Because you can get some severe burns. Same thing in a
Oh,
power plant, right? We've had systems where we had blowouts um in a on a HRSG, and
okay.
steam was coming right through a hole in the heat recovery steam generator. And I had guys on a stack doing stack testing during a startup, and they had to use the stack as a buffer between them and hot steam coming out. And it came out like it was whistling. And we're in the middle of Malvern, Arkansas, and cops are showing up at the gate because people are calling, right? And thinking the plant exploded when it just, was just steam coming out of high pressure
Hmm.
um, through a small opening, and basically how to get the guys down safely, and you have to react, in a safe manner, and stuff like that. So yeah, I mean, seen a lot of
Absolutely.
different things in the field, and um, so yeah, you learn a lot.
Well, let me ask you off that. And, you talk about like the steam example, which is crazy, and just some of the different things in the steel mill, some of the other places that, you've been in. What do you kind of jump to the future here? What are your thoughts on, a lot of the trends and, some of your predictions with how this is going to all affect the power market? Because you're seeing boots on the
Yeah,
ground firsthand what's shaping out. I know offline, you and I were even talking about electric cars, or you hear about AI, or you hear about data centers in different parts of the country. Um, that's been a very requested answer that I've gotten from listeners. What are your thoughts with some of these things that are happening? How this is going to play out?
yeah, real good question, and that's something I didn't see. I mean, look, didn't see that coming about a year ago, year and a, 2 years ago. But let's take
Mm-hmm.
a step back in order to talk about the future. One of the things that we did back in the late 20 teens, since 2012, since
Mm-hmm.
Obama, right? We were looking at the shutdown of coal plants, okay? And our system, in order to talk about AI in the future and data centers, let's talk about what was going on just prior to that, what we've been
Mm-hmm.
dealing with over the last 15 years. And so you're talking about the shutdown of all these coal plants, right? Because greenhouse gases, coal ash, all that,
Mm-hmm.
and competing in the market, right? And at the time they wanted EPA to dictate how a coal plant operated, and that was unprecedented, right? Unconstitutional, all that kind of stuff. And I worked with a lot of attorneys during that time to do the analysis and what have you. In fact, that's how my old Smoky Power presentations, which is all over my LinkedIn um, profile. You can find it. I've given that presentation multiple times. Last time I
Mm-hmm.
gave it was in 2023. People asked me to give it again, thought it was relevant, and I thought it was over in 2019.
Mm-hmm.
But you're looking at baseload generation coming offline, right? Because our grid, and you got to talk about the grid at the same time. Our grid was built to handle baseload generation,
Mm-hmm.
not the intermittent power generation that we have on today. Now, look, there's a place for renewables. Don't get me wrong. But it's an all of the above approach, and you got to be smart. Now, batteries have come a long way in terms of handling that, right? Handling the ebbs and flows of the inconsistent volts that come across the system, and most importantly, the amps. And the
Mm-hmm.
batteries can mimic that such that you're not missing a beat. And I'll get into that story now, but with the shutdown of all that baseload generation, now you're starting to see, with the data centers and the need for power. I mean, we've been stagnant in power growth. The
Mm-hmm.
average, you know, power growth in this country was less than 1%, and in the Gulf Coast, maybe 2%, right? Because
Mm-hmm.
of industry and things like that. But now
Mm-hmm.
you're seeing 2% plus across the country project. Now that's a lot of power, okay? I
Mm-hmm.
mean, in Texas, we probably have 150 gigawatts already.
Mm-hmm.
Our peak, on the ground, our peak capacity or peak generation was like 85 um, gigawatts, and that's usually in the summer.
Mm-hmm.
But you're starting to see that's going to project to 130, 140 going
Mm-hmm.
forward. And I probably misspoke. We don't have 150 now, but that's where they want to go, right? We probably have just over 100, maybe 110 or 120. I forget the number. You can Google what's actually on the ground. But my point is that the AI data centers, the need for power is unprecedented. We haven't seen this growth since the early 2000s, right? And all the big three in the gas turbine market, Siemens, Mitsubishi, GE, I mean, you can't get a slot before 2030 or so right now, right? So they're sold out. Now you're looking at the smaller, solar turbines, the gen sets, the gas engines like Wärtsilä, Cat, Jenbacher, right? The next line. Rolls-Royce is the other turbine manufacturer that's probably fourth or fifth. So you're starting to see the smaller players start, their lead times are starting to creep up. But one of the things that happened during COVID as well, Evan, was transformers, switchgear, all the ancillary equipment that you needed for substations and things like that. That supply chain started, I mean, dwindling as well, or the lead time started going out 2 years, 3 years for that type of equipment because you couldn't get it. That was another big thing that came out of COVID. So now it's a snowball effect, right? So it's about speed to market, speed to power, I should say, speed to power. Because these data centers can be built tomorrow. But the question is, can you get the power to power those data centers? Right now, they're talking about large load tariffs along the system among various states, right? Because these, the 10 kilowatt servers are gone. They're now 100 kilowatt and string them together. You're talking about, a megawatt, a gigawatt, data centers, gigawatt of data centers and up. And so it's power intensive. And so now you're looking at, Trump's trying to put delay the shutdown of all these older coal plants because we need the generation. And the other thing we need to is invest in the transmission, right? Some states have done that, especially in Texas over the years with CREZ and getting the power from like the renewables, wind and solar out in West Texas out to the load centers. And when I say load centers, I mean the cities, Dallas, Austin, Houston. So you got to build transmission to get that there. And that was the CREZ lines, and we're still paying for it in our bills. So you have to build out the transmission system as well. And they're talking about putting in 745 kVs and building these super highways. And AEP was talking about that back in 2000, if I remember, 2008, 2009, they wanted to do that, maybe a couple of years before that. But yeah, transmission is going to be a key, another bottleneck. That's why people are looking at behind the meter solutions for power generation. So they're going to co-locate a power plant, call it what you will. They're going to put in gen sets or turbines with maybe batteries to power the data center next door. And they'll worry about the interconnection later, because the interconnection is going to take 2 to 3 years to do with all the modeling and the studies that go along with it. And so, yeah, I mean, it's unprecedented what we're seeing, and it's going to put a strain on the grid. Okay. I'll just give you an example. Back in 2023, summer of 2023, Labor Day comes here in Texas. All the gas turbines, we had 100-degree days, like for over 100 days straight. After Labor Day, the gas turbines shut down after running for maintenance. Okay, well then it's still hot at 5, 6 o'clock in the evenings. It's still 100 degrees, but the solar intensity goes down. All the solar that we put in. Then what's going to back it up? And you don't have enough wind, so what's backing it up? We hit EA2 situations, emergency situations, several times that year, especially in the shoulder months of September, October. Early October is so hot. Because the turbines were down, and the batteries are what saved the grid. Okay, and these batteries were smaller, under 10 megawatts. They didn't have to go through the interconnection process with ERCOT, which runs the grid here in Texas. So they were getting built by doing these deals with the local utilities, building them near subsidy. But they were the ones that actually saved the grid from faltering. Because if you can imagine the ERCOT grid faltering, we'd be down for a month. I mean, it happened during Uri, right, where we had the cold weather impact. So batteries proved themselves to be worth their weight in gold and at that time. And since then, more and more batteries have been built. So they're the developers looking to make a windfall. I mean, the money, you weren't getting, 150, 60, $70,000 an hour for these units
Hmm.
anymore, right? The prices have come down, but those systems have saved the grid, and so now we got to be smarter about it when we're going forward with all the AI and the power consumption from um, from these AI data centers, right? We saw some of that with the blockchain coming in during COVID, right after
Hmm.
COVID here in Texas,
Hmm.
and um, and so now here in Texas we got Senate Bill 6, which gives utilities the right to curtail the data center, right,
Hmm.
in terms of feeding them power if they're connected to the grid. And
Hmm.
and that utility also includes a gas utility. And so if you're still behind the meter and getting gas from Centerpoint or Atmos up in the Dallas-Fort Worth area, they have the right to cut you off too. And so you're gonna have to figure that out and put in your N+1, N+2, and 5.9 reliability,
Hmm.
right? I mean, my first introduction to data centers was we were looking to do a data center was at Trigen in 2000, 2001 for the DIRTS organization in Manhattan,
Hmm.
and this was before I came to Texas. And 9/11 wound up ruining that project. But we were putting in, we had to hire an MIT professor to figure out, we're going to put in 6 Solar Taurus 70s, if I remember right. And it turned out we had to put one more to make it 7 for the N+1 for to meet the 4.9's reliability at that time. But
Hmm.
again, 9/11 came and that ruined that project. But I learned a lot at that time about the backups and the reliability for these data centers. And at that time, they weren't as big as what we're talking about today.
Yeah.
So it's unprecedented what we're seeing, and it's going to take a mix of, like I said, all the above approach. It's going to, the wind and the solar, and we got that's going to be sped up, and it's going to be sped up into next year by
Hmm.
July 4th about getting that steel in the ground. But you
Hmm.
got batteries too to support that, and they fared better. But the turbines and the engines are what's gonna that reliability is what's needed because the CPUs and the chips they need that constant, right? They don't need this. They need the
Yeah.
constant flow of power for them to work right.
And I think that's so exciting. I mean, I didn't even think about it, like how you were talking about going all the way back to like 08, 09, but even
Mm,
these new technologies, crypto, NVIDIA,
yep.
AMD, all these chipsets, it's almost like you were saying, it's the infrastructure is going through, it needs a new infrastructure in order to sustain this and so forth. I know we're wrapping up on the half hour here, so I guess my final question to you is for those looking to break into this space, and with the current set and what's to come, like you were talking about, any places you suggest someone to start? So I know with other guests I've spoken with in the past, sometimes it's a book, sometimes it's a conference, sometimes it's a resource, and talk with these folks. What would you recommend for someone who's listening to, this and seeing like, oh, I would love to get into this space?
Yeah. So if you're a power junkie like me, and you got to understand, power is a key to a lot of this stuff. It's also gotten me. Just one more thought is power has also gotten me into the oil and gas and other chemicals, sustainable, aviation fuels, biofuels, things like that, because you need power in order to make you know gas to liquids or aviation fuel, sustainable aviation fuels with biomass. You got to use a Fischer-Tropsch process. That Fischer-Tropsch process requires catalyst. That catalyst needs to be hot all the time. And how are you going to
Mm,
keep it hot? You need power.
mm,
So, a lot of the precedents for a lot of these, you know, gas liquids and power to X and not X being. Some people think of X as being digital. It's not. It's about power to X. X being cleaner fuels, whether it's hydrogen
mm,
or biofuels, things like that. You need power.
mm.
So I would get dragged or involved in those projects because of the power component. And then being a chemical engineer, I would, I understood the process. So, but if someone wants to is very interested, it's an exciting time right now to be in the energy industry. Okay, oil and gas, power. I mean, they're mixing together. To be honest with you, right? Because all the oil and gas guys are starting to get into the data center space and AI. As well. And here in Texas, they used to permit by rules and getting permits in 45 days, 60
Mhm.
days. Now you got to put in these power plants and do combustion, right? Well, you trigger in power generation. I was saying we sneeze, we trigger the alphabet soup of environmental regulations, right? From an air quality standpoint. So you got PSD permitting, new source review, non-attainment new source review, depending on where you're at.
Mhm.
So you don't get into that in oil and gas per se, because in Texas you got permit by rules that can cover you, and
Mhm.
it's the small scale. But so this is now where power is integrating with oil and gas, and it's exciting. So
Mhm.
where do you go? You got to go to some conferences. I'll tell you, Power Gen, obviously I'm on the Power Gen Technical Committee, been on that committee for 14 years now. That's
Mhm.
coming up in January in San Antonio. You have RE Plus if you're into the renewables, like a lot of us folks that were into thermal generation or have migrated into renewables. Why? Because that's where the market was going. So we had to pivot as well, right?
Mhm.
It's like our cheese has moved, right? Who moved my cheese? Well, our cheese has moved into renewables, and now it's starting to migrate back. And you have guys like me, all the guys that did the thermal plants, they're all retired, right? So
Mhm.
you just have to start bringing them back. But there are guys like me that are still in the industry that know how they operate, how to get them built, and things of that nature. So yeah, RE Plus, Power Gen. If you're into the digital transformation, Distributech, which is also run by the same folks at Power Gen, that'll be in San Diego I believe, in March of
Mhm.
26. So that's the digital transformation and electrification of the grid and everything else that goes along with it, right? So
Mhm.
those are some of the conferences. There's InfoCast has a bunch of regional conferences around renewables and storage and solar and what have you. And now you're starting to get the data center conferences. They're
Mhm.
all out there. Um, Data Center Power Exchange. There was one in Denver recently I was at. There was one in San Antonio. You just can't be at all of them, right? But you gotta find those conferences and try to attend them. I mean, I'm sure the universities out there and the colleges, they're gonna have these similar programs, right? From an education standpoint. I'm
Mhm.
going to talk about some of this stuff in more detail than what I skimmed the surface about during our discussions here today. So yeah, that's
Well,
that's
no,
what I
I
recommend.
guys, if what I'm gonna do, and Pete, thanks again for being here today. I am gonna in the bio and in all over our social media, I will include Pete's LinkedIn. I would definitely encourage you. Please feel free to reach out to him and so forth. But I'd call that a wrap, and I couldn't have asked for a better guest. Pete, thanks for being on.
Thank you, Evan. My pleasure. Nice being with you all today, and looking forward to hearing your feedback, right? And if you have any questions, feel free and reach out.
All right, thanks, Pete.
All right. Thanks, Evan.